Hi everyone, welcome to this lesson. In this lesson, we will make an introduction to Kafka Consumer and learn the Kafka Consumer working principles. As we mentioned in the producer part, Kafka holds the data which we call logs or events in a data structure called topics. And inside the topics, it has one or more partitions to store the data. Kafka producer writes the data at the end of a partition, while a consumer will read the data starting from beginning of a partition. And when it is done with the data, consumer send a commit request to broker so that there will be an offset per consumer per partition to remember the latest record that is read. This way, consumer will continue reading the new data instead of reading the same data again. Each consumer belongs to a consumer group ID, and Kafka distributes partitions to consumers based on this consumer group ID. Each partition is strictly assigned to a single consumer in a consumer group. Therefore, it is not possible to assign the same partition to more than one consumer. This is to prevent conflicts with the offset values and make consuming easier. Different consumer groups with different IDs can read the same data from the same partition. So Kafka allows to read the same data more than once, but for that, you need to create a new consumer group and read the data again. For maximum concurrency, it is wise to set consumer number as equal to the partition number. If we create more consumers than partition numbers, after assigning each partition to a consumer, some consumers will be idle, as it is not possible to assign a single partition to more than one consumer. There is a poll timeout in Kafka Consumer, and setting it to a too high value will cause to wait very long time and causes long delays in application. And setting it to a small value, on the other hand, will cause a lot of CPU cycles happening, causing CPU stall. To start from beginning with a new consumer group, we can set the auto-offset reset property to earliest, which has default value of latest, which is the last committed offset. You can use assign method to set tracing offset explicitly. You can also use custom consumer rebalance listener when subscribing, and override on partition assign method, and then use consumer seek to beginning method. Here we see the diagram of a Kafka consumer. On the right side, we see the producer, which produces data according to a partition strategy, which can be based on a hashing with a key, where hash of key modulo number of partitions will give the target partition number. Or it can simply based on round robin, which will write to each partition one by one. And on the left, we are seeing a consumer group with 3 consumers, and since there are 3 partitions on the Kafka topic in this picture, each consumer will be assigned to a single partition. And as we mentioned, each consumer will hold an offset individually to follow the last item it read. If you have single consumer with multiple partitions, there will be no concurrent work on multiple partitions by default. But we can still use multiple threads while consuming partitions. This should be implemented on the client side. As I mentioned previously, we can scale by the partition number, so adding a new partition gives us a chance to create a new consumer and use new resources for this new partition consuming. And for each consumer assigned to a single partition, we can still create more threads on the client side. And note that more threads will mean more TCP connections to Kafka broker. There are 3 types of delivery semantics in Kafka: at least once, at most once, and exactly once. This behavior relies on the consumer strategy and the acknowledge property on the client side. For example, if you commit after processing the data, the commit operation might fail, but you already processed the data. So in the next poll, you will read the same data and it will imply at least once behavior. However, if you commit before processing, and if you get error during processing data, you might lose some data, which will imply at most once semantic. Exactly once requires to coordinate between producer and consumer and using transactions starting from the producer part. There is a transaction Kafka API, which will start transaction from producer and use the same transaction in the consumer part. Normally, autocommit is set to true on consumer client, so it does a commit after a configured timer and reset the timer. But keep in mind that, in some scenarios, you might still encounter an error while using autocommit set to true, because a failure can always happen. So you might need to implement some rollback mechanism or use strict exactly once semantic depending on your needs. But if you say that at least once is good for your requirements, you do not need to think about this. We will use Spring Kafka to ease the development on the consumer part as we did in the producer part. And we can still set the consumer concurrency level and set the consumer properties as we will see in the coding section. And here are the consumer properties that we will be focusing on, which I will explain again in the coding section, although you might guess some of their meaning from the name. Alright, I will see you in the next section.